if I choose a value for x that's to the right of this nasty looking number, I'll just pick one up out of thin air. How about a billion? If I plug a billion in for x, do you guys agree everything here is positive? And so I think my original function is increasing over the interval. However, if I choose a value of x really, really close to 0, just slightly positive, my numerator is positive. But if x is really close to 0, I think my numerator is going to be negative. Denominator is positive, numerator is negative, the ratio is going to be negative. That means my original function changed from decreasing to increasing about that particular critical number. So I think that critical number yields a local mean. Actually, if you look at my picture, it's definitely the absolute main point. Oh shoot, did I goof up, you guys? Did I not test the other side of 0?
You don't have
That's
to.
okay, because this isn't giving me any meaningful values for x in terms of the problem situation. X can't be negative, so I reject it. What do you think? I know I'm talking fast, so I'm trying to get through the exam.
I just thought it was kind of confusing in the direction because you asked in terms of length. So I was thinking that it was a rectangle and with the x and
Oh.
yeah.
I wasn't trying to be tricky, and I think I originally said this got a square base. I was trying to be clear, even if I failed. I was trying. All right. Yes.
Can we do number 6, please?
Number 6. Better grab some of the exam. Get the right number 6.
It was the one you originally.
Oh, is it really? Oh, you guys, I get to steal my picture.
What did the answer end up being over here?
That one is
Yeah, I just asked for the length of the base. And so that is the answer. But I justified it. Actually, I remember grading your exams. A lot of you would just come in and say, oh, here's a critical number, therefore must be the answer. That's why in the beginning of the exam I said very clearly, justify all claims for extreme limit. Number 6, I get to steal this picture. However, this time around, whoops, I have a surface area that's fixed at 100 square inches. And I'm actually now trying to find the length of the base that will maximize the volume of the box. Well, let's see what I dive in and write down a nifty little formula that allows me to compute the volume of such a box. I think the volume is going to be computed by looking at the area of the base times the height. Here too, like in my last example, I think I'm really in trouble. Because I'm expressing v as a function of more than one variable, I better take a quick break and try to find some kind of constraint relationship between x and y. But the constraint relationship is the area, the surface area. And if the area of the base is going to be x squared, the area of one of the lateral sides is x times y, then certainly 4 times that gives the total area of the 4 lateral sides. I'll add it to the area of the base to get the total surface area, which is 100 square inches. Let me solve for one variable in terms of the other. I'm tired. I want to do a lot of work. I think there's a bit of work solving for x in terms of y, but I think there's very little work in solving for y in terms of x. Solving for y in terms of x merely gives me this difference divided by 4x. I'll pick it up off the import, slap it in for y over here, and you check out what I've accomplished. I've accomplished expressing v as a function in a single variable. Specifically, I said, specifically a function of the variable x. In my usual fashion, I will use my math skills to clean this mess up. I think v of x is nothing more than 1/4 times an x, oh, I misspoke, everybody. I meant to say 100x minus x cubed. And a differentiator, that just gives me 1/4 times 100 minus 3x squared. And that being the case, I'll build myself yet again another nifty little number line. I will plot the critical number that I see. Actually, there's 2 of them, isn't there? Is that a positive 10 over root 3? And a negative 1? In testing these 3 intervals. If x is equal to 1 billion, we'll check that out. 100 minus 3 times 1 billion squared is clearly negative. But if x is equal to 0, I get a positive value for my derivative function. And if x is to the left of negative 10 over root 3, I just don't care. I'm not dealing with negative numbers. And so I think my volume function, the original volume function, is changing from increasing to decreasing about that critical number. Well, that clearly means then I think 10 over root 3 is going to yield the maximum value for the volume.
If we didn't draw that little graph out, how much points would you get?
That was your justification for extrema, and I got to look at my little rubric that I used to grade. It looks like it was worth 4 points. Anybody else?
Can we look at the extra credit even though it's
It's
Oh, that was
extra
such a
credit.
fun question.
It's extra credit. Extra credit.
Oh, I see, I'm sorry. Yes, when I was a university student, I was a language major, can't you tell? Ay, ay, ay.
You had extrema on the mind.
I got one.
I said you had extrema on the mind.
So, f of x is equal to cosine of x plus cosine 2x. So determine all local extrema? Usual business, you guys. Let's dive in and differentiate all over the place. And I think f prime of x is equal to 0 simply when my sine of x plus 2 times the sine of 2x is equal to 0. Oh, you guys, I can't solve this equation conveniently because the inputs for these sine functions is different. I better use my double angle identity, which says that another name for the sine of 2x is 2 times the sine of x times the cosine of x. But that must mean when I factor out a sine of x, that here's what's left over. Now, in using my principle of zero products, I'll proclaim that either the first factor is equal to 0 or the second factor is. Uh-oh, everybody, I'm serious, I got a sign error. I apologize. Can I change that? I should be negative 1. So on a number line, let's go ahead and plot all the critical numbers that live between 0 and 3 pi. Well, the sine of an angle is going to be 0. Doesn't that mean the angle is going to be 0? Pi, 2 pi, or 3 pi. But if I have another angle's cosine is negative 1/4, which corner would that live when it comes to the circle? Second. And I think that angle is going to be nothing more than 1/4 revolution pi, backed up by the reference angle, which is the inverse cosine of 1/4. And so I think it's simply going to be right here, at pi minus the inverse cosine of 1/4. But I think there's another one in the third quadrant, on the other side of pi, located at pi plus the inverse cosine of 1/4. And then I think there's another one just right in front of 3 pi, but that's going to be nothing more than this one plus 2 pi. And so I think that's just simply going to be a 3 pi minus the inverse cosine of 1/4.
Can you explain why you did sine x plus 2 sine x 2x is equal to 0? Like,
Well, if you
why
think
did you
about it,
drop the negatives?
well, if you think about it, the question really is find local extrema. So I went ahead and differentiated. I was just simply trying to find critical numbers. And so I took my first derivative function, set it equal to 0. So I just put these two pieces right here equal to 0. In my head, I multiplied both sides by negative 1 because I could.
Okay.
I was just getting rid of the negatives. And now I can test these intervals, and you can figure out which ones gives local maxes, which one gives local mins.
They're all just going to be toggle switches, right?
Yeah, they're all going to be toggle switches. And so it turns out to be the case that everything's positive here, and then negative, and positive, negative, positive, negative. And who cares what happens after that? What do you think? Not bad, was it?
If we had time to do it.
It was just a
Yeah.
second. I did it in 60 seconds.
What are these values that you have
The critical numbers. They're the values of x that allow me to have my first derivative function equal to
I'm sorry, I couldn't see anything when you were doing it.
You mean, how did I come up with the pi minus inverse cosine of a
Yes.
quarter? I did this. In my head, I was looking at the Cartesian plane, x-axis, y-axis. Now, I think an angle whose cosine is negative 1/4 is going to live here in the second quadrant or the third quadrant. Now, I just think the easiest way to generate this angle in red in standard position is to rotate 1 full half revolution and back up by this amount of rotation here, but that's just a reference angle for this x. And so I think that's just simply the inverse cosine of positive 1/4. Now, if you really wanted to, you could do this. I think this angle in red is also considered just the inverse cosine of negative 1/4. If you want to write it that way, that's fine too. I think they're equivalent. They both, I should say, they both have the same terminal side. Okay. Brad, I'm sorry to keep doing this. What section are we in?
It was 45.
What section?
The 4 point. No, it wasn't 4.6. It's 4.5.
4.5.
Yeah. Well, yeah, but yeah, we did. We had to do 45. Pretty sure.
I have 743 on.
That was 45.
I think it was 45 odd. But yeah, really, the only thing I want to know, because all that's really easy, but I just want to know how they got the percent error, because everything aside from the first like 5 problems, I got I couldn't get the percent error for it because like I was doing 100 times approx minus exact divided by exact, and that wasn't working on any of these other problems. So I was just wondering if there was another way of getting the percent error aside from doing that calculation.
No.
It's weird. Because, yeah, I plugged that into a calculator. I had exact values of, like, 2.008298. And
Okay, do this. In your table of values, here's x. And if x is 8.1,
yeah.
can you give me the exact value?
The exact value is 2.008298. And, I mean, it just goes on forever, but that's just where I stopped.
Gotcha. And for the linear approximation?
It's 2.0083. And that one just goes on forever, too, but that's just where I stopped.
And so I think to come up with the percent error, all you need to do is look at the difference of these two. Divide by the exact value. Now, I'm going to be a little off because I rounded it a little too soon with this one, I didn't with that one. But that's all you're going to do is you're going to compute that ratio and see what you get. Yeah, just tell me what you get.
It's like 0.000000995.
Okay, now stop for a minute. Count how many zeros you have here after the decimal point, to the right of the decimal point.
So 1, 2, 3, 4, 5, 6.
Oh, that's all just 6?
Yeah.
Jesus.
Just use scientific notation.
What's that?
So just use scientific notation.
Yeah, I know. I didn't know there were going to be that many zeros when you rounded it off, to be honest. So I think this is equivalent to 0.1234 zeros as a percent. And you're saying the author came up with something different?
No, I think he got scientific. He must have rounded it or something. So you don't multiply that by 100?
I just did. I mean, going from here to here, I multiplied by 100,
Oh,
so I
okay.
guess my percent's simple. I moved it by decimal over 2 places.
No, they got like 1.717 times 10 to the negative 3.
Say it a little louder.
1.717 times 10 to the negative 3. So I have no idea how they got that.
Harry Potter.
Yes, back in my head.
And they have the same linear or the same values as I put in there.
When we do percent error in physics, we use a different formula. Does it matter?
What do you use?
It's experimental times observed over, it's like, it's the difference times the,
Actual minus theoretical over theoretical.
yeah, but it's times 1/2 over the denominator. I can write it, but it's hard to say it.
No, I see it. I see it. This is different though, only because I don't have an answer to your question, sorry. I don't have an answer to your question.
Looks wrong.
Yeah, because they have the same linear approximation and exact value, and then they get like some weird number that I don't know how they got to that.
I agree with your answer. Well, I agree with this was on the board, if that's your answer.
Okay, because
But again, I got a little rounding error in there.
yeah, it didn't work for any of these other problems.
You know, you guys just gotta remember, this is the first edition. I have no idea where the errors are. So. Are you happy with that though, Brad?
Yeah.
Okay, I agree. Let's do it again.